On the evening of June 30th, 2021, a small Canadian village called Lytton, British Columbia, population roughly 250 people, ceased to exist in under 30 minutes. 3 days earlier, Lytton had already broken Canada's all-time heat record. Then it broke it again. Then, on June 29th, it broke it a third straight day, hitting 121.3 degrees Fahrenheit, 49.6 degrees Celsius, the hottest temperature ever recorded anywhere in the country. Hotter than anything ever measured in Las Vegas or Death Valley on that particular date. Reporters from around the world were still writing stories about the number when residents smelled smoke. A wildfire, driven by wind gusts topping 70 kilometers an hour and fed by vegetation baked bone dry by days of unprecedented heat, tore into town from the surrounding hills. The mayor later said it took about 15 minutes from the first sign of smoke for the entire town to be engulfed. 90% of Lytton burned to the ground. 2 people died trying to escape. Just one province over and one border south, the heat had already turned lethal in a much quieter way. In British Columbia alone, coroners recorded well over 600 sudden deaths in the space of about 2 weeks, nearly triple the normal rate, almost all of them linked to heat. Across the border in Oregon and Washington, temperatures in Portland and Seattle shattered all-time records, with Portland topping out at 116 degrees, a number so far outside anything the region's building codes, power grids, or even its residents were prepared for that hospitals began filling with heat stroke patients faster than staff could process them. When researchers finished totaling the damage months later, the combined death toll across the Pacific Northwest and Western Canada from that single event, now known simply as the 2021 heat dome, had climbed past 4,100 people. Scientists studying the disaster afterward concluded that global warming had made an event of that magnitude roughly 150 times more likely than it would have been a century earlier. And here is the detail that should genuinely unsettle you. The weather pattern responsible for burning Lytton to the ground and killing more than 1,000 people across 2 countries was not some freak. 1 in a million occurrence built from mysterious forces nobody understands. It was a heat dome, one of the most common and most predictable extreme weather setups on the planet. The exact same kind of pattern that forms somewhere over North America nearly every single summer. The only question is never really whether one will form. It is how strong it gets, how long it parks itself in one place, and what it sets in motion once it does. Because a heat dome rarely travels alone. That is the part almost nobody talks about, and it is the part that makes this particular weather pattern so uniquely dangerous. A heat dome does not just bake the ground underneath it. It acts like an engine, and everything happening along its edges. The violent thunderstorms, the tornado risk, the flash flooding, even the strange quiet that sometimes falls over the tropical Atlantic during hurricane season can trace back to the exact same dome of trapped, superheated air. Understanding how a heat dome works is really understanding how an entire week of seemingly unrelated disasters, extreme heat in one region, violent storms in another, and an eerie hurricane lull somewhere else entirely, can all be pieces of a single connected machine. So let's start with the heat itself, because that is where the danger always begins. Even though it rarely gets the dramatic headlines that a tornado or a hurricane gets. Picture a massive ridge of high pressure parking itself over a region and simply refusing to move. Meteorologists sometimes describe it exactly like a lid on a pot. Someone turns the burner up and then claps a heavy lid on top so nothing can escape. Underneath that lid, air sinks, and sinking air compresses and heats up even further, the same principle that makes a bicycle pump warm when you use it. Clouds cannot form to block the sun, wind cannot push the hot air out. Day after day, the same air mass just keeps cooking in place. And the ground, the pavement, the buildings, all of it acts like a battery, storing up more and more heat that has nowhere to go, even after the sun sets. Meteorologists measure the strength of a heat dome using something called the 500 millibar geopotential height, a technical way of describing how thick and warm the lower atmosphere has become beneath the ridge. During the 2021 Pacific Northwest event, that measurement shattered records across British Columbia and Washington by a margin scientists described as almost statistically impossible under the climate of past decades, an anomaly so extreme that some researchers initially wondered if their models were malfunctioning before confirming the readings were real. That is part of what makes heat domes so unnerving to the people who study them for a living. Unlike a hurricane, which announces itself days in advance as a clearly defined spinning system on satellite imagery, a heat dome can look, on paper, like nothing more dramatic than a stubborn area of high pressure and clear skies, the exact kind of forecast that sounds pleasant rather than dangerous to anyone glancing at a weather app. That last detail is the one that catches so many people off guard, and it may be the single most dangerous feature of any heat dome event. Under normal circumstances, your body gets a break overnight. Temperatures drop, and even a few hours of cooler air lets your core temperature recover from a brutal day. But under a heat dome, nighttime temperatures often barely fall at all. You go to bed hot, you sleep hot, and you wake up already behind on recovery before the sun has even fully risen. Multiply that across 4, 5, 6 consecutive days, and you get a slow-motion medical emergency that builds invisibly inside people's homes, especially for anyone without reliable air conditioning, anyone elderly, anyone with a chronic health condition, or anyone whose job keeps them outdoors for hours at a stretch, with little shade and few breaks. And that invisibility is exactly why heat is, year after year, the deadliest weather phenomenon in the United States, more deadly than tornadoes, more deadly than hurricanes, more deadly than flooding, and it is not particularly close. According to the National Oceanic and Atmospheric Administration, heat has killed an average of roughly 180 Americans a year over the past 3 decades, well ahead of the yearly averages for flooding, tornadoes, hurricanes, and lightning combined. The Centers for Disease Control, using a broader method that captures heat's role in heart attacks, kidney failure, and other conditions that rarely get listed as heat deaths on a certificate, puts the real toll dramatically higher, north of 2,000 deaths in some recent years, making heat not just the deadliest weather event in the country, but arguably one of the most undercounted public health threats in America. The single deadliest heat event in modern American history remains the July 1995 Chicago heat wave, when a dome of trapped, humid air sat over the Midwest for barely a week and killed more than 700 people in Chicago alone, most of them elderly residents living in homes without air conditioning, in neighborhoods where hospitals were caught completely off guard by the sudden flood of patients. Nobody films a heat wave the way they film a tornado ripping through a subdivision. There is no dramatic funnel cloud, no wall of water, nothing that trends on social media in real time. It just quietly, relentlessly wears the body down, one hot night after another, until it becomes fatal. And that is precisely why it kills so many more people than the disasters everyone assumes are more dangerous. So if you live under one of these domes, the advice is not complicated, but it is worth repeating because so few people actually follow it. Check on elderly neighbors and relatives, especially anyone living alone. Never leave a child or a pet inside a parked car, not even for a minute, because the interior of a car sitting in extreme heat can climb past 150 degrees in well under 15 minutes, a temperature that can be fatal in a shockingly short window. Drink water before you feel thirsty, because thirst is already a lagging signal that your body is behind. Stay indoors during peak afternoon heat if you possibly can, and if you have no choice but to be outside, take shade breaks and watch yourself and others for dizziness, confusion, or nausea, the early warning signs your body sends before something more serious sets in. Now here is where the story gets genuinely fascinating, because that same dome of trapped heat that is quietly endangering people underneath it is simultaneously doing something else entirely along its edges. It is building a factory for violent storms. The atmosphere hates imbalance. When one region gets extremely hot while the air just beyond its borders stays comparatively cool, the atmosphere works furiously to even things out, and the boundary where that hot, humid air collides with cooler, drier air rushing in from the north or west becomes one of the most volatile zones in all of meteorology. Add in the jet stream, that fast-moving river of wind several miles up in the atmosphere, running right along the northern edge of the dome, and you have every ingredient a violent storm needs stacked in the same place at the same time. It is not unlike shaking a soda bottle and then cracking the cap. All that built-up energy has to go somewhere, and where it goes is straight up fast, in the form of towering thunderstorms that can turn severe within minutes. This is the mechanism behind one of the most underappreciated disaster types in American weather, the derecho, a long-lived, fast-moving line of violent thunderstorms capable of producing widespread hurricane-force straight-line winds across hundreds of miles in a single afternoon and evening. The most infamous recent example tore across Iowa, Illinois, and Indiana in August of 2020, a storm complex that generated wind gusts over 140 miles an hour in places, flattened an estimated one-third of Iowa's entire corn and soybean crop for that year, and caused more than $11 billion in damage in a matter of hours, making it, by some measurements, one of the costliest thunderstorm events in United States history. Straight-line winds like that do not spin the way a tornado does, but at that intensity they do not need to. They can snap power poles, peel roofs off buildings, and turn unsecured objects into airborne projectiles capable of shattering windows and injuring anyone caught outside. Along that same volatile boundary, the atmosphere can also start to twist, and when it does, the danger escalates to something even more feared: the supercell. A supercell is a thunderstorm with its own internal rotating engine, formed when winds at different heights in the atmosphere blow from different directions and different speeds, a condition meteorologists call wind shear. When the winds closer to the ground come out of the south, while the winds higher up shift to blow more from the west, the entire storm begins to rotate as it rises, and that rotation is precisely the ingredient that allows a thunderstorm to produce very large hail the size of golf balls or larger, and the strongest, most destructive tornadoes on the planet. The United States sees more tornadoes than any other country on Earth by a wide margin, largely because nowhere else does warm, moist air from a body of water as large as the Gulf collide so reliably with cool, dry air pouring down from Canada across such a vast, flat stretch of land. On average, tornadoes kill around 70 Americans a year, and while that number is far lower than the toll from heat, a single violent tornado can erase an entire neighborhood in seconds, which is exactly why the visual, dramatic nature of tornadoes tends to dominate headlines even when heat is quietly killing far more people in the background. There's a reason meteorologists talk about this stretch of the country, roughly from central Texas up through Oklahoma, Kansas, Nebraska, and into the Dakotas and Minnesota, as the beating heart of American severe weather season. It sits at the perfect crossroads, warm, humid air pumping north out of the Gulf of Mexico, dry desert air spilling east off the Rockies, and cold, dense air diving south out of Canada, all converging over the same wide-open, relatively flat terrain with nothing to slow the collision down. Meteorologists sometimes only issue a low tornado risk for a given afternoon, and that risk assessment is not the same thing as a guarantee of safety. A corridor of shifting, strengthening, low-level winds late in the afternoon can be enough to take an ordinary-looking thunderstorm and set it spinning within minutes, even on a day officially rated as a lower-end risk. That is precisely why forecasters so often repeat the same piece of advice. Never treat a low tornado risk as a zero tornado risk, especially once the atmosphere is already primed by days of built-up heat and moisture. One detail about these storms deserves special attention because it is one of the most underestimated dangers in all of severe weather, when they strike overnight. During the day, people have a fighting chance. They can see the sky darkening, watch storm clouds take on that unmistakable greenish tint, notice rotation building in the clouds if a tornado is forming, and react. At night, none of that visual warning exists. All you have is sound, wind howling against the windows, thunder rattling the walls, and if the power goes out, total darkness while the house shakes around you. Studies of nighttime tornadoes have consistently found they are roughly twice as likely to be fatal as daytime tornadoes, largely because people are asleep, unable to see the sky, and dependent entirely on a phone alert or a weather radio to wake them in time. That single fact is why meteorologists so consistently urge people in tornado-prone regions to keep emergency alerts enabled on their phones, and ideally, keep a battery-powered weather radio in the house, because in the middle of the night, that alert may be the only warning you get before you need to be sheltering in a basement, or absent that, an interior room on the lowest floor away from all windows. Flooding tends to ride along behind these storm systems, rather than announcing itself as the headline threat, and that is exactly what makes it so treacherous. When round after round of thunderstorms tracks over the same stretch of ground day after day, a pattern meteorologists call training, because each new storm follows the last one along nearly the same path. The way train cars follow the same track, the ground simply runs out of capacity to absorb any more water. Rivers and creeks that handled the first round of rain just fine can be dangerously overwhelmed by the fourth or fifth round, hitting the same watershed within 72 hours. More people die each year from driving into flooded roadways than from almost any other single flood-related cause, which is exactly why the simplest piece of advice, turn around, don't drown, remains one of the most repeated warnings in all of American weather broadcasting. A road covered in moving water is never a shortcut, no matter how shallow it looks from the driver's seat, because it takes only about a foot of moving water to sweep a car off the pavement entirely. Now here is where the heat dome's influence stretches even further than most people realize, all the way out into the open Atlantic Ocean, hundreds of miles from anywhere the dome itself ever touches. Every hurricane season, meteorologists watch closely for a phenomenon that sounds like good news on the surface, but often is not. An unusually quiet stretch over the tropical Atlantic, with disturbance after disturbance trying and failing to organize into anything resembling a tropical storm. Often, the culprit is a climate pattern like El Niño, a periodic warming of Pacific Ocean waters that reshapes wind patterns across the entire globe. One of El Niño's signature effects is a dramatic increase in wind shear over the Atlantic, the very same kind of shear that helps supercells rotate over land, except here it works in the opposite direction, tearing budding tropical storms apart before they can ever organize into something dangerous. Think of it like trying to stack building blocks while someone keeps knocking the tower over before it can rise more than a few inches. That sounds like nothing but relief for anyone living along the Gulf or Atlantic coasts, and in the short term it often is. Fewer organized storms generally does mean fewer direct hits. But there is a catch that meteorologists watch nervously every single year. A quiet stretch like this develops, and it is this. All of that warm water sitting untouched beneath a quiet Atlantic does not simply evaporate or disappear. It keeps absorbing solar energy all summer long, with nothing coming along to churn it up, mix in cooler water from below, and release that stored heat gradually. The ocean essentially becomes a fully charged battery waiting for the right conditions to discharge all at once. If wind shear later relaxes, even briefly, later in the season, Any storm that manages to organize can suddenly access an enormous reservoir of stored energy, and it can intensify explosively, a phenomenon meteorologists call rapid intensification. There is no better example of just how terrifying that process can be than Hurricane Otis, which struck Acapulco, Mexico in October of 2023. Otis went from a relatively weak tropical storm to a catastrophic Category 5 hurricane with winds over 165 miles an hour in roughly 24 hours, one of the fastest intensification rates ever recorded anywhere on Earth, catching forecasters, emergency officials, and residents almost completely off guard. It made landfall as a major hurricane with barely any time for the kind of evacuation planning that normally takes days, and it remains one of the starkest warnings in modern meteorology that a quiet ocean is never the same thing as a safe one. Step back now and look at the entire picture, because once you see it laid out this way, the connections become impossible to unsee. One ridge of high pressure sits over a region and traps the air beneath it, creating the kind of extreme multi-day heat that kills more Americans every year than any other weather hazard combined. Precisely because it is slow, invisible, and easy to underestimate until it is too late. Along the northern and western edges of that same dome, the collision between trapped hot air and cooler air rushing in from outside fuels repeated rounds of severe thunderstorms, some producing damaging straight-line winds capable of leveling crops and snapping power poles across hundreds of miles, others spinning into supercells capable of dropping large hail and violent tornadoes, many of them striking at night when the danger is hardest to see coming and statistically most likely to prove fatal. Meanwhile, out over the open ocean, the broader atmospheric pattern responsible for that same heat dome can also suppress hurricane formation for weeks at a time through the very same wind shear, lulling coastal communities into a false sense of security while the ocean itself quietly stores up the exact kind of energy that, once released, can turn a quiet tropical wave into a catastrophic hurricane in a single day. It is, in every sense, one interconnected weather machine, not three separate disasters that happen to occur in the same general time frame. And understanding that connection is exactly what allows people to prepare for all three threats at once, rather than being caught off guard by any single one of them. None of this is meant to induce panic for its own sake. It is meant to close the gap between how dangerous these events actually are and how seriously most people tend to take them. Tornadoes and hurricanes get the dramatic footage, the sirens, the wall-to-wall news coverage, and rightly so because their destructive power is real and immediate. But heat rarely gets that same treatment, even though it is quietly the deadliest of them all, and a quiet Atlantic Ocean rarely gets treated with the wariness it deserves, even though history, from the Chicago heat wave of 1995 to the Lytton wildfire of 2021 to Hurricane Otis in 2023, keeps demonstrating just how quickly a seemingly manageable weather pattern can turn into a genuine disaster once its full mechanics kick into gear. The people of Lytton did not get a wildfire warning weeks in advance. They got 3 days of record heat. A fire that started as a wisp of smoke on a hillside, and roughly 15 minutes before their entire town was gone. The people of Chicago in 1995 did not see the death toll coming from a distance either, because heat rarely announces itself the way a funnel cloud does. What both of those events share with every heat dome that forms somewhere across North America nearly every summer is the same underlying architecture, the same lid clamped down over a region, the same trapped and rising energy, the same volatile boundary where storms are born, and the same broader atmospheric ripple effects reaching out toward the tropics. It is worth sitting with just how wide the gap is between public perception and the actual data on these threats. Ask most people to name the deadliest kind of weather in America, and the overwhelming majority will say hurricanes or tornadoes, the events with the most vivid, most shared, most memorable footage. Heat almost never comes to mind, largely because it rarely produces a single dramatic image the way a funnel cloud or a storm surge does. It shows up instead as a wave of quiet emergency room visits, a slow rise in cardiac arrests among elderly residents without air conditioning, a farm worker who collapses in a field with no witnesses nearby, deaths that get spread out across weeks and attributed on paper to heart failure or kidney complications, rather than the heat that triggered them. That invisibility is not an accident of bad luck. It is the defining feature of why heat remains simultaneously the deadliest and the most underestimated weather hazard the country faces almost every single summer. So the next time a forecaster mentions a heat dome building over the plains, or a ridge of high pressure setting up shop for a week, do not treat it as background noise before the more exciting part of the forecast. That dome is the whole story. It is the anchor that everything else, the extreme daytime highs, the dangerously warm overnight lows, the rounds of severe thunderstorms along its edges, the tornado risk that spikes precisely where hot and cool air collide, and even the strange, deceptive quiet that can settle over the tropical Atlantic hundreds of miles away, all traces back to. Respect the heat as much as you would respect a tornado warning, because the statistics are unambiguous about which one is actually more likely to take a life. Keep emergency alerts turned on before severe weather season ramps up in your region, not after the first siren sounds. Have a plan for where you would shelter if a storm rolled through at 2 in the morning while you were asleep. And if you live anywhere near the coast, remember that a quiet hurricane season is not the same thing as a safe one. Because the ocean does not forget the energy it has stored, it simply waits for the right moment to let it go. Understanding how these systems connect will not stop a heat dome from forming next summer, or the summer after that. But it can be the difference between watching a disaster unfold from a place of genuine preparedness and being caught as unaware as the people who once thought Lytton, British Columbia, was simply having an unusually hot week before their town was gone in less time than it takes to read this sentence twice. The pattern will keep repeating somewhere across North America nearly every year, and the only real variable left in the equation is whether the people standing underneath it are paying attention before it fully arrives, or only after the sirens, the smoke, or the flashing phone alert has already made the decision for them.